Well, it's close enough. And hello, everyone, and welcome back to Launchpad. I'm Christian Reddy, your friendly neighborhood astronomer. And 2020 is rapidly getting further and further into the rearview mirror. And I thought it would just be fun to talk about something that was relatively on brand. It seems like we had a couple of news stories in space news lately, or at least one particular news story, involving the idea that we may have detected an extraterrestrial signal coming from the star Proxima Centauri. Or not. Probably not. But there's, I thought it'd be kind of funny to, I don't know, it just seemed like a perfect way to kind of wind up in 2020. Like, why not? Sure, all the other problems we had this year, let's have aliens come invade. You never know. Okay, we'll get the autofocus working one of these days. Anyway, it's so great to see everybody here tonight. I'm so very pleased to see so many of you. Just want to say hello to some folks. I see Stephen Morgan. Good to see you, sir. Path Medic is here. And Path Medic, I hope your cat is doing better, my friend. And Surrogacy, so great to see you too. And yes, Surrogacy, I too would like to believe, but it doesn't matter what you and I believe. It only matters what is. And right now we don't know very much about what is, except the is seems to be a potential signal. You never know. I'm spammed out. Good to have you aboard. And there's a few other folks, but you know what? Let's get right to it because I did make a video, by the way, about that space signal. If you want to take a look at it, I'll have a link. I'll have a link in the chat, and I'll put a link in the description as well of this video. But I dropped a video yesterday on it just to offer a few of my thoughts. Speaking of someone who offers his thoughts quite a bit, my guest tonight is the host. Well, actually, there's a few things. He's got a pretty cool resume. My guest tonight is a research professor in astrophysics at the Institute for Advanced Computational Science at Stony Brook University and the Flatiron Institute in New York City, which I probably just mispronounced. But you may have seen him on TV in shows such as How the Universe Works on the Science Channel and Space Out on Discovery. He's the author of not one, but two... Well, I'll get to him in a second. Sorry, buddy. But he is the author of not one, but two books on space, Your Place in the Universe, Understanding Our Big Messy Existence, and How to Die in Space, A Journey Through Dangerous Astrophysical Phenomena. Please welcome my guest tonight. I also lovingly like to think of him as the space curmudgeon, Dr. Paul M. Sutter. Good evening, Paul. How are you?
Good evening, and that is very fair. I'm the guy that people bring on to crush all your hopes and dreams about space. I'm that guy.
Yeah, thanks, Paul. We appreciate your service. So Paul, I thought, why not? It just seemed like a perfect thing to talk about, just sort of like a fun topic. And by the way, if you haven't read How to Die in Space, I should mention that we are doing a giveaway of a copy of How to Die in Space. You see it right there. The man is holding it up. How to Die in Space by Paul M. Sutter. We're going to be giving that away, as well as a couple of items of Launchpad Astronomy swag. We'll be giving away a mug, and we'll be giving away a shirt. And the way we're going to do this is we're going to, toward the end, if you've been paying attention, we're going to ask a couple of questions, and whoever answers first, wins the prize, and we'll go with that. But maybe we'll stagger them out. What do you think, Paul? Should we stagger them out as we kind of go?
Yeah, let's have fun with it.
Great. Okay.
Let's tease everyone.
All right. We'll tease everyone, and we'll just drip these out as we go. So, Paul, like I said in my introduction, you are the host of the Ask a Spaceman podcast. I was wondering if you want to just talk a little bit about that and a little bit about your background in astrophysics.
Yeah, sure. So my podcast is super fun. It's hilarious. I do 2 episodes a month. They come out every other week. And I've been doing it for, I think 7 years now is when I started it. And the whole point is for me to talk about astrophysics without actually having to come up with the topics. And so it's Ask a Spaceman. I'm the spaceman. You go online to Twitter, Facebook, or email, or go to the show website, and you just send me questions. And then I pick from those questions and answer them. So we've explored so many topics in our 100+ episodes. We've talked about supernova. We've talked about the Big Bang. We've talked about how stars work. We've talked about string theory. We've talked about quantum field theory. We've talked about how we understand the atom exists, like all sorts of fun topics in astronomy and physics and astrophysics. And it's available on podcast distributors worldwide, all the normal, usual channels for getting podcast information into your phone and into your brain. And I also do it as a YouTube series on my channel here on YouTube, where every week I show short clips from the show. I don't do any graphics because I have absolutely no skills or time or money to do video graphics. So it's just me talking about some cool topic in astronomy. And so it's a way to comfort over your own home and the safety of your own home. And in terms of my background, I got my PhD in physics from the University of Illinois in 2011, specializing in computational cosmology. So I was building simulations of the universe and of galaxy clusters and of black holes, blown up stuff. It was super fun using giant computers. And then from there, I spent 3 years at the Paris Institute of Astrophysics in France as a postdoctoral fellow. And there I worked on a bunch of things. I worked with the Planck mission, studying the cosmic microwave background. I did a lot of investigations of cosmic voids, of finding the big empty patches, the regions in our universe, and using them to understand dark matter and dark energy. And then I also developed some interesting techniques for doing radio astronomy, some new image algorithm-y stuff to better understand radio data. And from there, I went to Trieste, Italy, where I spent 2 years at the observatory there, continuing these research lines. Then I came back. I'm from the Midwest. I'm from Ohio. I came back to Columbus, Ohio, and I had a joint position there both at the Department of Astronomy at The Ohio State University and as the chief scientist at the Center of Science and Industry. Did that for a few years, and then a year and a half ago, I moved to the New York area to devote myself full-time to outreach. I still maintain some academic positions at Stony Brook University and the Flatiron Institute, but I spend all my time yabbering on about astrophysics, people throwing questions at me, and me just doing my best, making it up as I go along.
Seems like we have a little bit of similarity in our careers. I tend to yammer on as well, and I've been to Canada, so I'm well traveled. Canada. No, I'm just kidding. No, seriously, Paul, that's an impressive background. That's an amazing resume, and I'm so glad you had a chance to share that with the audience, because I don't want people to think that he's just a guy that rants on space. No, he's a legit scientist, guys. He's a legit astrophysicist.
Right, because the qualifications to rant on YouTube are a camera.
Yeah, pretty much camera. Yeah, there you go. So, Paul, I wanted to talk about the book How to Die in Space. Like I said, I thought it would be a perfect way to wrap up 2020. But the way I was reading it, ahead of the show, and I got to tell you, it is a fun read. It is written in a very conversational. Folks, when you read it, you will hear Paul's voice in your head, just saying this to you. It's hilarious. Even his endnotes are funny, and it's written very tongue in cheek. But one thing that I was I'm glad you wrote it, and the reason for this is because I once a year I guest teach at a workshop for science fiction writers, and it's something that we talk about all the time: how to die in space. And so what I wanted to do tonight is talk a little bit more about your book, How to Die in Space, some of the different ways, or some of your favorite ways. And folks, I want to make sure that you have a chance to ask your questions tonight of Paul. And if anybody here is interested in going into space, I would love it if you could say yes, space me, something like that. And I want to just kind of take like a bit of an informal poll to see, who's keen to get into space and who's keen to say, I'm staying here. So let's talk a little bit about.
I'm staying down here.
You are, Paul? Okay, so why are you staying down here?
I've got a house. I have a very comfortable chair.
Well, but I mean temporarily, you go up for a few weeks, maybe,
Oh gosh, a few weeks. I don't know. I feel like in zero G, like my acid reflux would really get bad, and just it's gonna be, and my sinuses would stuff up, and then my bones would get weak.
Right.
I feel like it's less fun than people think.
I think there are astronauts who can agree with you on many respects. They have talked about feeling, all your bodily fluids are just able to float around inside of you, and so you always feel like you're congested all the time. You feel like you're a bit distended.
Like non-stop cold. Who wants that?
Well, but I mean, you can get inside a tin can, and turn on the heat, maybe, or you can just bask in the glow of the sun and fry to a crisp. And what do you think? Come on.
Oh gosh, and like it's all fraught with danger, and astronauts die, and I don't think my family would let me go, honestly, even if I wanted to. I'll do the vomit comet. I'll give you that. I'll do the thing that goes up and down.
Okay.
I'll do that. Maybe I'll do the Richard Branson space tourism thing, although that doesn't exactly have the best safety record.
Got a little bit of work.
I'm good in space for like a couple hours. I'll give you a couple hours.
Well, I'll say this much. It looks like just by a very quick and, skimming through our comments, it seems like there's a number, most of our audience are in favor of the, yes, I'll go up into space. But you know what? I tease you, but honestly, I completely respect. I would go because, bucket list, right? Vomit Comet, absolutely in a heartbeat, without question about it. But now, well, okay, we may have a convert, may have someone coming along, And by the way, did I mention tonight that Paul's giving away a ride on the... No, okay, we're not doing that. We're giving away...
I'll do it. I'll give away things that I have no control over. You know what? The first person to answer a trivia question right gets a free ticket to Mars.
There you go. Guaranteed. If if that same person answers a second question correctly, they'll get a ticket back. Anyway, so Paul,
they might also get a tank of oxygen.
So let's talk about those ways of dying in space, because again, the reason why, on a semi-serious note, what I thought was cool about the book is that, like I said, we talk about this all the time at a workshop, and also I think it's because science fiction kind of trains us to thinking that, well, space is just like being on a ship at the sea and off you go, and what I don't think people and even the TV shows don't do a very good job of all the time is showing you just how extremely dangerous what they're doing is. Even being on the Next Generation cruise ship Enterprise D is very, very dangerous. So can you tell us a little bit about some of the ways that you found to die in space in your research?
Yeah, the main point of the book, is to talk about really cool astrophysics. But the main point of the book is that the universe is trying to kill you and kill us all the time. And really just drive home how safe and protected we are here on the Earth, how good we have it. And then as soon as you go out into space and you want to explore the universe, you want to buzz around the galaxy, you want to see some black holes, you want to see planets forming. Okay, all that is awesome, and all that is exceedingly dangerous. And the universe has so many clever ways to kill you. It can smash you. It can irradiate you. It can tear you apart with magnetic fields. It can pull you into a black hole. Like, it's just in the vacuum of space itself. Like, as soon as you get outside of our atmosphere, it is dangerous. And everything, you're literally surrounded by something that is trying to kill you. And there are tiny little particles, subatomic particles called cosmic rays, which are constantly swimming through your body and snipping apart your DNA. Like, so you just can't get a break in space. And so it's just, yeah, if you want to go to space and explore, have fun, you're probably going to die.
So, all right. I think you've sold that aspect of it pretty well. But let's. I think there's also some room for some maybe clarifying some misconceptions.
Mhm.
For example, space itself. What is space? Let's make sure we're all. I mean, I know it sounds like a fundamental question or a simple question, but let's talk about what we mean when we say space. Are we talking about pretty nebulae and stars? Are we talking about planets? Are we talking about asteroids? What are we really talking about when we say space?
Right. And this is such a fun question because there is no strict definition of space, or there's multiple options you can choose for your definition of space. So you can define space to be everything but the Earth. So as soon as you're outside the Earth's atmosphere, you're in space. Even if you're on the surface of another planet or traveling through another galaxy, you're in space. Another definition you can choose is all the stuff or all the places in the universe that aren't currently occupied by things, like not occupied by a star or not occupied by a planet or not occupied by a nebula. If you list all the things you might encounter in the universe, all those things take up a comparatively tiny amount of volume. And then you have a whole bunch of volume that is basically nothing. And that is space. That is what we call the vacuum of space. It is the nothingness. It is the emptiness. It is the void through which you must travel in order to get to any other interesting place.
So Surrogacy says that well, we are actually in space, are we not?
Yeah,
Give
exactly. Like the Earth is a planet orbiting a star. And if you were to encounter some other random planet orbiting a random star, you would say, well, yeah, that planet is in space. It's right over there.
well, I
But for
think
historical
yeah.
reasons, we started here on the surface of the earth, so it has a special place in our hearts. And so we call this Earth and we call that space, even though we're all technically a part of the universe.
Well, and as Andrew says, spaceship Earth is what we live upon. So good point, Andrew. Thank you. So I guess then what I'd like to just kind of qualify the question a little bit further is, we're talking about, like I said, there's a few myths and misconceptions out there about the dangers of space,
Mhm.
which is not to undersell the true dangers of space travel. But suppose you were quote unquote spaced, right? You were kicked
Mhm.
out the airlock, and you held your breath for a little bit. Would you die instantly?
Right. This is such a common trope in sci-fi that is, as soon as you're exposed to the vacuum of space, you like freeze to death or you blow up or some of your eyes bulge out. Um, so the good news is that you do not die right away if you get exposed to vacuum. The bad news is you will die very, very soon and in a very gruesome way. So, first thing, you do not explode. You do not explode because, yes, there's a bunch of fluids and gases inside of you, and then there's vacuum outside of you. And you might think that this makes you blow up, but your skin is pretty strong. It's really good at holding your insides inside, so you're not going to blow up. The first thing that you will encounter when you are exposed to the vacuum of space is all the oils and sweat all over your skin and on your eyes. Everything will instantly freeze and evaporate, and that will cause some damage. You're going to get a pretty nasty like dry skin because of that. The next thing that's going to happen is you're going to lose all the air in your lungs. And the last thing you want to do is try to hold in that lungful of air, because if you hold in a lungful of air, you have a lot of air in here at 1 atmospheric pressure, and then you have 0 air pressure outside. So that air is want to go outside, and the squishy, fleshy parts of your throat are not meant or designed to hold a lungful of air against a vacuum. So if you don't let it go, it will force its way out, and you can imagine that's pretty nasty. It will damage your lungs. It will damage your throat, probably permanently. So if you get spaced, the air's going to want to go out. You just let it go. You're not going to be able to hold on to that breath, but you'll still be conscious. You'll still be feeling and experiencing all this. But what's going to happen in a matter of 10 to 20 seconds is that your brain will be deprived of oxygen because there's no air in space, but your heart is still pumping all of your blood, expecting to pick up oxygen from your lungs, but it doesn't. But it keeps on pumping. But then soon enough, your brain realizes, like, wait a minute, I'm running out of oxygen. And so it shuts down. You will lose consciousness in 10 to 20 seconds. You will swell up a little bit. All the fluids near the surface of your skin will expand. Your skin will hold you in, but you will puff up a little. It's called embolism, which is different than an embolism. This is called embolism. And within a couple minutes, you'll die because of lack of oxygen. But if you're recovered, you can be revived and you can go on to live a hopefully much less stressful life. The whole freezing.
Well, there you go. So you got that going.
Yeah, exactly.
Yeah, you know. All right, so that is just the danger of being in space, and I think that does point out that fundamental misconception. As soon as you're in space, you're dead. No, not yet.
You got a little bit of time. You got a little bit of time. It's still horrible, but
it's not, and it would not be a pleasant experience even while you were still alive, and even if you survive, it would be a very unpleasant experience.
Yeah, you're all flailing around. You're freezing cold. You've lost a lung full of air. Like, it is not going to be pretty or fun. You're swelling up.
So Funk Bob, love the name, dude, asks, do eyeballs pop out like in Total Recall? Now that's another thing. So let's talk about that scene in Total Recall, just for those who haven't seen it. You remember how that went, Paul? Or should I?
Yeah. Can we pull up a screen share?
Of course. You'll have to share your screen first, and then we'll bring that on up. Oh my
gosh, this is I'm gonna make it full screen here.
Well, you actually have to share your screen first.
Right.
Okay.
I'm making a full screen so you guys can see the full effect.
Oh, good. Okay.
Okay, here we go. There it is.
All right, so now I'm going to... There he is. Sounds like you were kind of waiting for that one, right?
The funniest thing about this scene is that, like, this is happening, and then they get back in air, and then they're just like fine. They're just like, oh yeah, I just pushed my eyeballs back in, and I can totally. There's no like burst blood vessels or hematomas or anything. Like, it's just like, oh no, it's just a temporary thing. Like you don't come back from this and be fine, folks. Like, this is gonna take some work to get you back. Man, that is bad. So this doesn't happen. First of all, you can't scream because Arnie is obviously screaming here, but you can't do that because there's no air for you to scream with.
And by the way, this is on Mars, and yes, Mars has an atmosphere, but it has an atmospheric pressure right now of something like less than 1%, right? About 1% of Earth's atmosphere.
It's basically a vacuum.
It's basically a vacuum, right? And so actually, and Gennaro points out, hey, at least you'll be passed out, right? Because Arnold shouldn't even be screaming. He should be, kind of out after about 20 seconds or so.
Yeah, exactly. And he would try to scream, but there's no air to force that through. So it'd be like, and no, your eyeballs don't bulge out because that's not a thing. It's just like, your eyeballs are actually pretty hard. I mean, it's up to you if you want to like touch your eyeballs right now, but they're actually like really solid things. And if you've ever done like cow eye dissections, like their eyeballs are surprisingly tough tissues.
That's cool. So let's see. Arnold at his best. Yeah, I'd say so, right? But a flesh wound. Yeah, you could say that. And of course, the good news is that it's not a tumor. Okay, all right. So all of the Arnold jokes and even showing that will probably get this channel demonetized for some DCMA thing. You can leave your screen up, Paul. I'll just come back to this shot whenever it's time to show something else. In the meantime, so believe it or not, you can actually share your screen on the back end. There you go. And then it'll be there for when we want to come back and take a look at something else. So anyway, so that's the challenge of just being in a low atmosphere or vacuum or near vacuum environment. Now let's talk a little bit about another way, I think, to die in space. Again, this is a bit of a misnomer. You would freeze to death. Right, and I think that's another misconception that we hear an awful lot about. Would you really freeze to death in every situation? Are there situations where you actually don't?
Right. So if you are in the full glare of the sun's light and you are close enough to the sun, you will never freeze because the sun will provide enough heat energy toward your body to keep the water in your body in a liquid state. And if you're too close, it'll just evaporate it because it's too hot. So you can think of the planets of the solar system. Like if you were to die on the surface of Mercury, the water in you would just evaporate because there's no liquid water on the surface of Mercury. If you were to die at the orbit of Mars, you would eventually freeze to death because liquid water cannot survive on the surface of Mars. And if you were to die right at the orbit of the Earth, you would probably stay nice and liquid because that's within the habitable zone of our sun. That's receiving enough sunlight energy to keep you liquid. So if you're close enough to a star, you won't freeze to death at all. And if you're too far away, it takes a long time to cool down objects. And especially it takes a long time to do it in space because there's no conduction, there's no convection. These two methods of transferring heat and energy are very, very efficient. The only thing left is radiation. You're glowing, you're emitting light in infrared. This is why infrared goggles actually work because they can see the emission of infrared light coming off your body.
Right.
And you're emitting about 100 watts. The human body emits about the same as a 100-watt incandescent bulb. And that's not a lot of energy. And it takes a lot of energy. You have to pull a lot of energy out in order to freeze it. So it actually takes a couple hours to freeze you. So it's that will eventually be your long-term fate.
Right.
But your more immediate concern is the lack of oxygen.
The actually and to that end, Sarkozy adds, actually, if we could breathe pure oxygen, 1/3 of the atmospheric pressure going to full vacuum for a short period could not be that unpleasant. If we,
I mean,
okay, right, because then you'd be
oxygenating.
oxygenating.
To zero is still a big jump.
Yeah, yeah. But I guess what he's pointing out is that, well, at least you'd be oxygenating your blood because it's pure oxygen. So you'd have as much oxygen that you can. Now, I'm not a biologist. I don't know. I'm not a doctor.
Yeah.
Yeah, that's out of my league.
Yeah. If you could have like a sealed face mask that you could breathe from to get oxygen, you could survive slightly longer.
Yeah, right.
It'll be extremely uncomfortable.
Right. One thing to add, though, to your point is that, being even in the presence of the sun, I mean, let's face it, when astronauts are doing EVAs, they are wearing these EVA suits. And yes, that's to keep them warm in orbital night or whenever they're in shadow and there's no sunlight hitting them. But as I understand, it's also to keep them cool when they are in sunlight. Because even at Earth's distance, even in the habitable zone, the sun is really hot and without an atmosphere, right?
Oh yeah, yeah. Like the EVA suits have to both cool and heat. Depending on the circumstances that they find themselves in. And they need these like super, super reflective visors to cut down on the glare of the sunlight. Like I said, space is nasty.
Well, the sun is also emitting some radiation that we have to talk about as well, right? And obviously it emits light. That's one form of radiation. What are some other forms of, let's say, not so good forms of radiation that the sun is pretty abundant in?
So the sun is a great emitter of ultraviolet radiation, most of which is blocked by our ozone layer, but a few specific wavelengths do sneak through, and that's what gives us all this skin cancer nonsense that we have to deal with our sunblock. It's just those few little wavelengths of ultraviolet radiation that make it through the atmosphere. The sun is also good at emitting X-rays, and X-rays are really, really fun when you're trying to use them to diagnose a broken bone. X-rays are really, really bad when you're trying to live and work in that environment. And so you're just getting this constant blast of high energy radiation. Now, other stars are going to be way worse. The sun isn't too bad about this. But the sun also emits constantly a stream of charged particles. These are electrons, these are protons, these are heavier nuclei. And these charged particles stream out of the sun at close to the speed of light. They flood the solar system. We call it the solar wind. Sometimes there's bigger blasts of them that we call coronal mass ejections. No matter what, they're horrible. They can literally irradiate you. They can melt your flesh. They can give you cancer. Like they can make you sick. Like this is just bad stuff. And this is from our sun. The star we depend on for life is also incredibly deadly.
Well, then you also mentioned cosmic rays. Funk Bob was asking, how many cosmic rays hit us folk on Earth? Now that's big important thing. We are talking about inside of Earth's atmosphere, more importantly,
Right.
the magnetosphere.
So, yeah, with our Earth, we have a couple defense mechanisms that absorb most of the cosmic rays that come on us. By the way, cosmic rays are the name we give to high energy charged particles streaming in from all over the universe, not just the sun. But when supernova go off, or active galactic nuclei, or blazars, or just whatever, they flood the universe with these particles. Our magnetic field is able to deflect a lot of low energy ones. And then our atmosphere is able to absorb a lot of the medium energy ones. So the cosmic ray comes in, and instead of hitting us on the ground, it hits an air molecule. And then it's okay. It took the damage for us. But the higher energy cosmic rays do make it down to surface level. And depending on the energy, so very loosely, if I just say roughly high energy cosmic rays, there's about one every second per cubic meter of volume. So your body is encountering or absorbing one of these high energy cosmic rays about once a second. If you do a lot of high altitude flying, like a lot of transcontinental flights, for example, your radiation dose from cosmic rays is going to be a little bit higher. Most of the time, these cosmic rays either just sail on through, or they hit like a random water molecule and nobody cares. But sometimes they're capable, they hit a strand of DNA. Just very unlucky. They can just snip apart that DNA. And when they do, this can sometimes lead to replication errors, which is another way of generating cancer. And so it's estimated that between 3 and maybe up to 10% of all cancers that we experience here on the surface of the earth are due to cosmic rays, are due to the sun, are due to supernova going off millions of years ago, all contribute to cancer rates here on the surface of the earth.
And that's bad. Okay,
That is bad, and that is bad. That's
is
basically
bad,
the end
yeah.
of every single chapter.
So actually, this kind of raises a related question. Jack was asking how many Roentgens. I'm probably mispronouncing that, even though I can write it out. How many are there in the ISS? I don't know off the top of my head. Do you know, Paul? I know they get quite a few more.
I do not know
Yeah.
the Rankin radiation dose up there on the ISS off the top of my head. I do know that a trip to Mars is one of the deadliest things you can do as a
Right.
human being,
Right.
because you have to spend 6 to 9 months in transit. Then you have to spend time on the surface, and Mars has no magnetic field or substantial atmosphere. And then you need 6 to 9 months back. So that, like, 1.5 to 2 years round trip to Mars is a serious problem when it comes to cancer rates and exposure to cosmic rays. It is a problem we do need to mitigate or solve, and one which we really don't have a viable solution for yet.
The best solution I've heard of is just huge, huge tanks of water.
Yeah, that
Which is-
can work. Okay, but then that just increases the mass of your ship.
Yes, it
And
does.
so either you need to loft it, you need to launch it, which is going to increase your launch
Nah,
cost.
screw that.
But
Get it from the
either
moon.
way, you have to propel it over to Mars, and like
Right.
every pound is
Yep.
going to cost you like $10,000 minimum or something like that.
Well, that's
And
to
so,
launch it off
yeah,
the surface of the Earth. But I'm saying let's get it from the. I think we will be okay digging it out of the ice caps on the polar caps on Mars. Not Mars. Sorry, the Moon. The polar craters, which are in permanent shadow. grab those out of there. Or if there is an abundance of water just underneath the lunar surface, as the SOFIA measurements indicated, possibly that as well. And then you've got something. But you're right. You still are going to have all that mass you now got to shove to get to Mars.
Well, and you still have to get to Mars. And like the lunar water, like the SOFIA measurements, if they're right, it's like 1 20-ounce bottle of water per cubic meter of lunar dirt.
Right. Now, what we're going to do is we're going to take, we're going to bring up another related question. But then, folks, then we're going to go and do our first giveaway. And I'll tell you about how we're going to do that in a moment. But Renan BR says, what is the density of particles in space? Does that density vary based on location inside the solar system? Okay, wow. So we have a few different regimes that Renan is asking about. So let's talk a little bit about the local ISM density, or I shouldn't say even ISM. I should say the local solar density. Do you happen to know?
Right. So the our solar system, if you were to go out beyond the Earth's atmosphere and just travel around in interplanetary space, the particles that you would encounter, yes, there are particles coming in from outside the universe, but most of the particles are coming from the sun. The density is very low. I think it's like 10 to the minus 29 particles per cubic centimeter, something like that. It's a small number. It's somewhere in that ballpark off the top, or grams per centimeter cubed, if I get the units right. Once you leave the solar system, like the Voyager spacecraft have done, once you've left the region dominated by the solar wind from the sun, you enter a different regime that's dominated by all the particles contributed by all the stars in our environment. It's a slightly lower density than it is in the solar system. And then you can leave the galaxy altogether and go out into intragalactic space. And that's an even lower density. And then you can go out in between the galaxies, the great structures of our universe. You can go into the cosmic voids, which are vast expanses, millions of light years long, containing almost absolutely nothing. And that is where you'll encounter the lowest densities of anything in the universe. As for the numbers, I just don't have them off the top of my head.
No, that's quite all right. I think you got some relatively good ones. I mean, basically the rule of thumb, at least in our galaxy, is on average, and this is a huge important caveat, folks. We're talking about on average, because there's a lot of particles per cubic centimeter here on Earth. Even the air is ultra dense compared to the interstellar medium. But on average, the typical, what we think of as like the vacuum of space, it's about 1 atom per cubic centimeter, or cubic meter, excuse me, if I remember correctly. So, and if anybody here knows for sure what it is, you can also let us know. So what I'd like to do now is get to our first trivia question. And what we're playing for right now is a Launchpad astronomy mug, which you can find. You know, if I had thought about this a little bit more detail, I would have had like a nice graphic made up of it. But this will be for a coffee mug or tea mug, if you're like me, for that says Launchpad Astronomy. And you will have your choice, my friend, of the design. You can have the Saturn Launchpad logo, or you can have my Space Force Launchpad logo. You know, whatever you like to do. But my question for everybody, and the way I want you to get guys to play this at home, is if you're in the chat, I'm going to ask you the question, and then you're going to type your answer in the chat. And what you want to do, this is important, folks. You see at the top of your chat window where it says Top Chat? You want to click that. Change that to Live Chat. Switch that over to live chat, get over there, and get ready to type in your answer. Then what I'm going to do is I'm going to let your answers come in, give everybody a couple seconds to ring in, and then we're just going to scroll up, we're just going to take a look, try to find the first person that answered it. And, I should probably mention this other caveat too. You will probably swear that you answered first, but it's not what you see on your end, it's what we see on our end, and that's just because of the way the system works. Going through all of the switches and so forth. You're probably going to see your answer. I've done a few of these myself, and I've been like, I answered first. Yeah, well, guess what? So, are you ready, ladies and gentlemen? The question
I'm ready.
All right. Now, Paul, you might not want to answer this one.
there.
Just saying, you might want to hold it up. Just hang in there, okay? I'll mute you if I have to, but I don't think I have to. I think you can hang in there. So, the deal is this. The question is this. For those of us on Earth, okay, protected by the magnetic field of Earth and the atmosphere and all that kind of stuff, approximately, what is the approximate rate of cosmic rays that strike you and me and folks, you know, how many cosmic rays would you say you get hit? At what rate? You know, once a month, once in a lifetime, you know, just type in your answer in the chat. What is the rate at which cosmic rays hit your body on average? Okay, on average. So we're going to give some folks here a chance to respond. And this is basically just like, yeah, we just talked about this, which is why I thought I'd ask this question. Okay, so I'm seeing a number of responses. I'm seeing once a week. I'm seeing billions of hits per second. I see about 100 cosmic rays per second. But the very first person that answered correctly, okay, one minute per meter. No, actually, meter. Anyway, but the first person that answered it correctly is Gennaro Monaco, 1 per second. Ladies and gentlemen, we have a winner, 1 per second. Well done, Gennaro. Yay, we have Gennaro. All right, good job. Yay, let's play that again. Okay, there you go. All right, so Gennaro, I'm going to need to get your mailing address, man, and we'll get you your coffee mug. Well done, Gennaro. All right, so now what I thought we could do is pivot a little bit over to more of like the threats just in interstellar travel. Okay, we've talked about being nuked by the sun and all that kind of stuff. We're probably going to encounter a few less cosmic rays, but are we really going to encounter no cosmic rays in interstellar space?
No, in fact, it actually gets worse in interstellar space because you don't have the magnetic field of the Earth. You don't have the Earth's atmosphere to protect you. And then you're also losing the sun's magnetic field and the solar wind itself, this stream of particles emanating from the sun constantly, itself is a protective barrier. And then the galaxy's magnetic field acts as a barrier. So the deeper you go into the void, the more and more cosmic rays you actually encounter. It just gets worse and worse the farther you get from home.
So, if you're getting worse and you're getting into even higher radiation, by the way, where are those cosmic rays coming from? If they're not, I mean, some of them are coming from the sun, and obviously some are coming from other stars, but where are the highest energy cosmic rays coming from?
The absolute highest energy cosmic rays, we actually don't know where they come from, and it's a bit of a mystery. But the step right below that, the very high energy cosmic rays, these things come from supernova explosions. They come from stars colliding. They come from giant black holes that are feeding on material. Like any high energy process in the universe, if it's powerful, it's going to generate these cosmic rays. And there are enough of these processes happening all the time that even though our universe is gigantic, our universe is 13 billion years old, has a radius of 92 billion light years, even though it's giant and old, there are enough of these high energy events happening all the time that our universe is just flooded in these cosmic rays.
And I'm glad you point that out. And also I want to thank the Finnish Monster for asking this question. Quasars. Now remember, quasars, these are the cores of very active galaxies, often from very early in the history of the universe, and they're billions of light years away. Are they a threat?
Quasars are not a threat unless you get close to them, which is one of the themes of the book. Like, you should enjoy all this astrophysics stuff from a position of safety. Quasars are a feature of the young universe. We don't really have quasars operating in the present day universe. They only happened when the universe was much younger. And so we only see them very, very, very far away as a relic of the young universe. And so the nearest quasar is tens of millions of light years away. It's not even close to being a threat. But if you were to travel to them, or if you were to run around in the young universe, it would be a different story.
Okay, well, and there you go. And speaking of quasars, they are associated with something else that people have mentioned. Well, they're not the only source of these phenomena. But I was going to put it up on screen here. I can't find it. But gamma ray bursts. I understand that those are very, very bad. Why?
I mean, just listen to the name. Gamma ray. So gamma ray, these are the highest energy form of radiation possible. Burst of gamma ray. So a lot of gamma rays. This is just not going to be a good thing. Gamma ray bursts are a category of astronomical object. And this is something you see a lot of in astronomy, where astronomers give a name to something because they detect it on the sky before we understand it. And then the understanding comes later. And sometimes the name fits. Sometimes the name, it means the complete opposite of what's actually generating it. Sometimes the name is a general category that can have subclasses of different kinds of events, and it's into that gamma ray burst fits. So gamma ray burst is just a burst of gamma rays. It turns out there are multiple causes of bursts of gamma rays. Certain stellar mergers can generate bursts of gamma rays. Magnetars, highly magnetized neutron stars, can glitch out and spaz out and send out a burst of gamma rays. We can potentially get gamma ray bursts from objects falling into black holes and getting torn apart. So again, if it's a high energy event, if things are crashing into each other, or things are blowing up, or things are getting eaten, they're going to release a flood of gamma rays. They're going to release a flood of cosmic rays. They're going to release a flood of rays that are going to kill you if you're too close.
These are extremely high energy events, and that energy's got to go somewhere. Okay, fair enough. Fair enough. So, so this relates to another question that you mentioned stellar mergers, and I know we're not talking about stellar mergers, but Renan asks, does our galaxy will that generate a quasar when it collides with Andromeda? Okay, so we have a galaxy that's heading right for us. What do we do?
Yeah, I mentioned that quasars are a feature of the young universe. Another feature of the young universe, our universe is smaller. We live in an expanding universe. In the past, our universe took up less volume. All the galaxies were close together, and they were merging more often. And we think that quasars are an artifact of galaxy mergers, that when they crash into each other and they merge, all the two giant black holes at their center merge together, and then there's a bunch of gas floating around, and it gets swallowed, and it spews out all this energy. The Milky Way galaxy is currently headed towards Andromeda, our nearest neighbor. We will collide in about 5 billion years, and it might trigger an event that is powerful enough to be classified as a quasar. It's a temporary situation. It may not, depending on exactly how the whole thing falls through, but it seems likely that we will experience this kind of quasar event if we're still around.
Right, right. I mean, if we are available, and oh my gosh, holy moly, super chat from Dr. Brian Keating. Thank you so much. Oh my gosh, and which
hey, Brian, I was just on Brian's show like a month ago on his YouTube channel.
The guy, yeah. I mean, just a quick shout out, and look at this guy. Look at this guy right here. He says, "Hey guys, I love your work. Thanks for being an inspiration." What are you talking about? You're an inspiration to me. You and Paul and the other big cool cats. By the way, Brian Keating is going to be a guest on my live stream at the end of January. So big tease there. But thank you so much, and we appreciate it. So to Brian's question, which end scenario would You like to which end scenario? Okay, now this is end survive, so we probably aren't talking about the end of the universe, and we're not talking about the end of Paul. Um, what do you think would be the one you'd like to be able to see?
I can't resist. I can't resist the temptation to fall into a supermassive black hole because supermassive black holes, you can actually survive, as far as we understand, survive the entry into them. That you're not going to be torn apart by gravity. You eventually will die. Once you fall in, you can't get out. You will reach the singularity. You will be destroyed into oblivion, blah, blah, blah. But the actual entry into the black hole, as far as we understand it, you can survive. And the event horizon of a black hole, the surface of a black hole, is one of the biggest mysteries in astrophysics. We do not fully understand what happens at the surface of a black hole. And you can find out by visiting it and surviving it. So all you have to do is build a rocket, travel 25,000 light years, get to the center of the Milky Way galaxy, find Sagittarius A star, survive all the storms of radiation and turbulence and all that, and then plunge yourself into the black hole. And then you can solve some of the biggest mysteries in physics before you die. Downside, you can't tell anyone about it, which is a bit of a bummer.
Right, that's gonna hurt with publication, you know. I mean,
you know what? If I'm about to die into complete oblivion in a singularity, I'm not exactly worrying about my impact factor, my H index, or anything.
Yeah, but I've got
bigger things.
But you'd have like total posterity. You'd be like in the books with Einstein. Those guys, like, hey, Paul went in the black hole. He told us what happened. No, you can't do that because you're not getting, nothing's getting out. By the way, we had another. Oh, thank you so much, Mathematic. Wow, thank you so much for the super chat. So generous of you, man. I really do appreciate that, and just wanted to also I hope the cat's okay. I hope your cat's doing well. But thank you so much. We really do appreciate that. And we even had another. Oh, Circus-E. Wow. Now what's interesting about this is that I'm looking on YouTube and I see this really cool coffee mug thing coming up, right? But then, like, on our streaming software, it describes it like this: pair character exaggeratingly stretching his arm forward over a cup of coffee. Ecan Live, you gotta support the super stickers, but thanks, man. And yeah,
we perish. That's right, Dr. Brian Keating.
And yeah, I guess we probably ought to like try to increase the energy a little bit. So I guess Circus, he's trying to tell us that we're being too boring for him. So, but anyway, Publish in Paris, thank you so much for those. So let me now, Paul, would you like to ask a trivia question? This will be for our second giveaway. Now, this one's going to be for, well, I was going to say we could do another Launchpad giveaway, and then we could do yours as sort of like the grand prize.
Let's do it. I love that.
All right. So this one's going to be for a Launchpad Astronomy t-shirt. A t-shirt. And this you'll have to get with me and let me know your size and style that you'd like and all that kind of stuff. I'll send you some choices and we'll work it out, okay? But for a Launchpad Astronomy t-shirt, Paul, do you have a question you'd like to suggest? Putting you on the spot, because we're literally making up these questions as we go.
Yep. I've got a question. To the nearest billion, how old is our universe?
To the nearest billion, how old is our universe?
You can round if you want.
Okay.
You don't need to be ultra precise here.
Okay, great. So to the nearest billion, how old is our universe? And you can round. Okay, you heard what he says, right? So you can definitely round that out, and we'll go there. So seeing a few answers coming in. See, I'm seeing 5, seeing 16, seeing 9, 4, 6. Well, 42. I mean, that seems like a good one, right?
I suppose we can construct a unit system where the answer is 42.
Okay, I think that's wise. But you know what, though? The first person that I think answered the question correctly, I think it was Sebastian Clark with 14.
I believe it was.
Hey, Sebastian, well done. You, sir, are getting a from the Peanut Gallery. Thank you so much. We're going to be sending you a T-shirt, and thank you very kindly. You guys are so much fun. What can I say? This is kind of 36 billion. My first time here. Love the subjects here. I'm an amateur astronomer and science gal. but don't have the telescope I used to have. It was stolen. Oh, okay.
Ouch.
We need to set up, Carlissa, a GoFundMe to get a new telescope. It is wrong for any astronomer to be without their telescope. Let's make that happen. So what I want to do is, let's maybe, and look at this. And Casey, thank you so much. Oh wait, 4 billion. No, it was something else that Casey said. I thought it was something. She said, "Look at this. Look at this. My two favorites." Paul and
Right.
Paul and Pathmatic are her two favorites. That's so sweet of her to say that. That's so great. So let's I think we had, let's see. No, you didn't miss all of the live. You're here. We're all here. And of course, this will be available for replay as well. So you can go back and you can watch this and just kind of see how the conversation evolved
Relive all the fun.
or devolved, as the case may be. Well, let's talk a little bit about one more thing. So we've talked about everything from, being here in our universe. Everything from being here in our solar system, interstellar threats, even potentially intergalactic threats. And by that, what we mean is, if you're just too close to the wrong quasar when it goes off and it's aimed at you and all that kind of stuff. But suppose you manage to survive all of that, okay? Mm-hmm. And because you're getting in your 10,000 steps every day, even if it's just on a little treadmill, and you survive and you live indefinitely, you're good to go, right?
I mean, eventually you're going to meet your fate. I'm sorry, but time marches forward, and eventually something's going to get you. And the longer you live in the universe and the further you get to explore, one of the benefits is that the exotic that you're going to get to see. You're going to get to see the rare things, the strange things, and some stuff we're not even exactly sure about yet. Things like or relics from the Big Bang itself, these wrinkles in space-time called cosmic strings. You might meet a new best friend. You might be the one to figure out if we're alone in the universe or not. Here's a hint. It's not a Proxima Centauri. That I won't get started on that horrible, horrible news story about these radio signals coming from Proxima Centauri, but that's for a different day. It's not there.
I had my own little rant about that.
But you might encounter alien civilizations if you travel far enough. You might understand the nature of dark matter and dark energy. You might understand the ultimate fate of the universe before you kick it. And I wish you pleasant journeys and good luck.
Well, there we go. And I think it is. There is one question that we had earlier. So basically, the universe is probably going to meet its heat death, and therefore you're going to have to meet yours as well, right? So we're not getting out of here alive, I guess, is sort of the thing.
Yeah, I mean, you're stuck here. Yeah. Sorry.
Yeah. Okay. Well, we're stuck here, but you know what? It's kind of cool that we can be here for at least a little while, because I'd rather be than not be. I mean, I was dead for 13.7.8 billion years, and I gotta, before. Yeah, well, I mean, it didn't.
So boring.
Honestly, it didn't inconvenience me in the slightest bit, So there's that as well. So let's see here. We have Happy New Year, a Happy New Year wish, and a Happy New Year from everybody. And oh my gosh, Zach, hey, thank you so much. Oh my goodness, look at this. A signal from Proxima Centauri was trying to reach you about your car's extended warranty.
That's a good one.
That's wonderful. So, let's see. Well, I think we are about ready for our final giveaway. And Paul, would you like to ask the question again?
Let's do it for the book for How to Die in Space, and I'm going to autograph it too. We'll sign it. I'll sign it before I ship it out.
And so again, winners, you'll need to contact me. And by the way, I should also say this: if you won, and please. Honor system, folks. Okay, let's be good. Netizens here. Honor system, please email me if you go to the about page of my YouTube channel. Okay, you'll see for business inquiries. You hit that, and my email address will come up. You can hit that, and then you can send me an email at my email address. Okay, I'm purposely not going to say it right now because only the people who really want to stalk me should have to work for it.
You gotta work for it.
Yeah, right, exactly. But please do find me there. or leave me a comment if you can't get to that, whatever. Or just leave a comment in this video. Get in touch. We'll make it work. Okay, Paul, for the book.
All right.
For How to Die.
For the book. Are you guys ready?
And remember, folks, keep it on live chat.
Yep.
Okay.
Keep it live. Let's do it. This is for the book. What is the name of a highly magnetized neutron star, aka the most awesome word in all of astrophysics?
The most highly, I'd play the Jeopardy theme, but I know we'd get totally canned, But
I'm gonna think it in my head.
Yeah, I got that in my head as well. Don't even hum it. But we have a few responses already coming in. Okay, and I think that there's a lot of correct responses, I must say.
There is.
They're doing pretty well on this one. So let's say, I know it's probably bad television to do this with your hands, but we're all friends here. Why not? Yeah. It's the end of 2020, so let's do that. All right. So the first person that I believe answered it correctly, and let's see if you agree with me, Paul. I have that one. Pathmetic, put that up on eBay. $8. Hey, what? Okay. No, it is in fact the top response I'm seeing is from Sebastian Clark Magnetar. Well,
Sebastian Clark again.
Oh, wait. Sebastian, what do you say? Well, shall we? Let's see. He won already, right? He already won.
You already got. I think he got the shirt.
I think he got the shirt. What do you say, Sebastian? If it's okay with you, we give it to the next person that answered correctly, and that I believe would be Renan BR.
Renan BR. This book is this very one that I'm holding. Look, yeah, I'm touching it, and soon you will be touching it too.
You will be. Wow. Yeah. So, Renan, you've just won a copy of Paul's book with a free sample of Paul's DNA thrown in for good measure. So this has been a lot of fun. I really want to thank all of you for joining us tonight. I especially want to thank Paul. Thank you so much for coming on.
Absolutely. Thank you so much for this was a super fun chat. You're an amazing host. Awesome crew over here. I love live shows. I love audience interactions. You've got a great audience here.
I'm very flattered, and I know that I really do. And yes, Casey, just to let you know, I was before him. I don't know if you heard what I was saying before. The way YouTube does work, and I'm just pointing this out for everybody, the way this all kind of works is that, there's like local buffers and local caches and so forth. So yeah, you probably will see your response come up even ahead of someone else's, and it sucks, I know, but at the end of the day, we can only see what we can only see. But hey, Gennaro, thank you so much. Oh my goodness, super chat from Gennaro. Awesome. Happy 2021. Be well. Thank you very kindly. Child of God, thank you, Christian Reddy and Paul Sutter. It's our pleasure. We're so happy to have you all here. And again, my thanks to Paul for joining me tonight. And just wanted to just kind of close tonight with just a few things. First of all, I do need to thank my Patreon supporters over here for all of their support. Thank you so much from the bottom of my heart for supporting Launchpad Astronomy and keeping the channel going, and I'll get a camera with autofocus. Come on, camera, let's go. Okay. And I also just want to say that if you'd like to help support Launchpad for the also keep in mind these folks were here: Michael Dowling, Stephen J. Morgan. Hey, Stephen's here as a matter of fact. And how cool is that? And Morrison Wild and Anna for her intergalactic level support. Now, if you would like to help support Launchpad for the price of a cup of coffee every month, for the price of a cup of coffee every month, for the hell is it? I don't know. Anyway, the point is that what you do is you go over to patreon.com/Launchpad Astronomy. There it is. You go to Launchpad Astronomy and Launchpad Astro on patreon.com. You can chip in a few bucks every month, and it really helps out quite a bit. Am I still making noises here, or did my audio just die out? No, I'm still here. Okay, great. So as you can see, I'm a professional. Anyway, and finally, if you'd like to join me on this journey through this incredible universe of ours, well, please make sure you subscribe and ring that notification bell so that you don't miss out on any new videos. Until next time, I wish you all a very wonderful and safe and a very happy new year. Take care, everyone. Stay well and stay curious, my friends. Good night.